NASA thinks there's a way to get to Mars in only 3 days. Evan Gu of Universe Today, this is on phys.org. It's a 2016 article, but I found it very interesting, and I think you will too. We've achieved amazing things, they go to say, by using chemical rockets to place satellites in orbits, and people on the moon, and place rovers on the surface of the moon. We've even used ion drives to reach destinations farther afield in our solar system. But reaching other stars or reducing our travel time to Mars or other planets will require another method of travel, one that can approach relativistic speeds. We can execute missions to Mars, but it takes several months for a vehicle to reach the red planet. Even then, most missions have to be launched during the most optimal launch windows, which only occur every 2 years. But the minds at NASA never stop thinking about this problem, and now Dr. Philip Lubin, physics professor at the University of California, Santa Barbara, may have come up with something, photonic propulsion, which he thinks could reduce time travel from Earth to Mars to just 3 days for a 100 kilogram craft. That's about 220 pounds. The system is called Deep In, or Direct Propulsion for Interstellar Exploration. The general idea is that we have achieved relativistic speeds in the laboratory, but have not taken that technology, which is electromagnetic in nature rather than chemical, and used it outside the laboratory. In short, we can propel individual particles to near the speed of light inside particle accelerators, but we have not expanded that technology to the macro level. Directed energy propulsion differs from rocket technology in a fundamental way. The propulsion system stays at home, and the craft does not carry any fuel or propellant. Instead, the craft would carry a system of reflectors which would be struck with an aimed stream of photons, propelling the craft forward, and the whole system is modular and scalable. If that's not tantalizing enough, the system can also be used to deflect hazardous space debris and to detect other technological civilizations. As talked about in this paper, detecting these types of systems in use by other civilizations may be our best hope for discovering those civilizations. There's a roadmap for using this system, and it starts small. At first, Deep In would be used to launch small cube satellites. The feedback from this phase would then inform the next step, which would be to test for a unit for defending the ISS from space debris, and from them the systems would meet goals of increasing complexity, from launching satellites to LEO, which is low Earth orbit, and GEO, geostationary orbit, all the way up to asteroid deflection and planetary defense. And after that, relativistic drives capable of interstellar travel is the goal. There are lots of questions still to be answered, of course, like what happens when a vehicle at near the speed of light hits a tiny meteorite. But those questions will be asked and answered as the system is developed and its capabilities grow. Obviously, Deep In has the potential to bring other stars into reach. This system could deliver probes to some of the more promising exoplanets and give humanity its first detailed look at other solar systems. If Deep In can be successfully scaled up, as Lumen says, then it will be transformational technology. This is from Universe Today, and it's on phys.org. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.